We decided on Monday as the secondary 2 team to rearrange things just a little bit. So we will be, this is actually 7.2, just a typo, I forgot to fix it. We are skipping 7.3 completely, and you will learn that next year. And then we're going to take 2 extra sections that didn't really, like we chopped some things up and rearranged them. So you will be soon getting a packet for 7.5 and 7.6. So in this unit you'll have 7.1, 7.2, 7.4, 5, and 6, and then we'll review it. So the schedule is updated on my calendar. You guys will be testing on the 17th of February. So 2 weeks from Friday. If you wanted to fix your test, you have until the 10th to do it, so 1 week from Friday. Just one more load. Get that done. Any questions on that so far? Okay, cool. Let's move on. Today's not too hard. You've done everything like you've done all of this before. Now it's just giving it kind of the formal way to look at it. This is function notation. Function, you're, I hope, at least a little familiar with that. You've seen f of x before. You nod your head or shake it, like confirm. At least it looks a little familiar. You may not know what it means, but if you've seen it, I hope. F of x is just kind of the formal way of saying y. So you're used to saying y equals yada yada yada, right? F of x is just more of the formal way to do the same thing. What it does is it shows you that whatever you're looking at is a function, and the input variable that you're using is x. So last unit we had several examples where we used time, right? So we might have used something that said f of t, where t would be the time variable. You don't have to write that down. But x is the input variable. That's the number that can change. And this is the output variable. So this right here is read f of x. I'll do that right there. Again, I'm sorry about the bouncing. It's pretty bad. It's really bad. So, like I said, last night we had to come through. There's a gigantic cable right here, my old one, because we had to cut it out of there. And anyway, so we were up in the ladder up in the rafters. I mean, with a ladder, we weren't like up there, but so there are these cables connecting, like the projector is up on the pole, and then the pole has a plate right here, so it's not actually connected to the ceiling, which means it's not the people wrestling above us. It's not a wrestling class, like I thought it was. I don't know, maybe it is a little bit, I don't know, it's making it wobble.
Take them in the plate and you both are connecting the projector to the pole.
Okay. Anyway, but then there's these cable ties that connect the plate to something, and I don't know what it was. My husband loosened those, thinking that if I tied, anyway, apparently loosening them was the wrong idea. So we're going to come back tonight and tighten them and see if that will help the problem. Because until then, you just have to like watch the screen like this, and you'll be better. Or when you get a seizure, because of all the wobbling, just go in the turn. Okay, traditionally functions are referred to like f of x, g of x, h of x, and so on. There's not really an I because I is imaginary numbers. J has to do with imaginary numbers, sort of. But K, we would go to. So these traditionally, f of x is almost always the first one you would see. So you could see G, H, and other letters as well. So consider these functions. You've got f of x equals this, g of x equals x squared plus 1, h of x, k of x. To evaluate the function, this is what it would look like. So this is saying f of 2. What this is asking is, if x is 0, if x is 2, what would my y value be? What would my function be? So if I'm trying to say f of 2, I know this might sound like a stupid question, but which of those 4 functions would I plug the 2 into? F, because it's the f variable, right, or the f letter. So I'm going to take my f function, and everywhere there's an x, I'm going to plug in a 2. And then I will evaluate what that is. So 7 times 2 is 14, minus 3 is 11. And again, what that means is, if my function is at 2, where would the y value be? Square up here at 11, and the graph would look something like this. So that's what that means. Okay, to find g of 4, everywhere there's an x, what do you do? Plug in a 4. And I'm using the g function because of the g letter right there. 4 squared is 16, plus 2 is? Fantastic. Alright, so let's do it again. I use the a function. Alright, everywhere there's an x, I put a 6. 6 plus 3 is the square root of 9. Is it 3 or is it plus or minus 3? Did you put the square root on there? Or was the square root already there? It's already there, so it just wants the positive. So it's just 3. If you are the one putting the square root on, you'll do the plus or minus. But if it's already there, it just wants the positive. Alright, try the part D on your own. Everywhere there is an x, plug in a 0. Alright, so everywhere there's an x, we plug in a 0. So 2 times 0 plus 1 over 0 minus 2, that's 0. That's negative 2. Are you okay with that? It's a really ugly one, huh? Feel better about that. Alright, what about the next one? Is it possible to plug a variable into a variable? This is how yes, we are going to do this. So, if we look at our g function, this is my x variable, right? What am I inputting into this x variable? 5x. So, everywhere there's an x now, what am I going to put? 5x. And then we just have to know how to simplify that. If I'm trying to square the 5x, do I square the 5, do I square the x, or do I square both? Both. So this would be 25 x squared plus 2. Yes. No, because this f function could change to a different function. Like, it'll define what it is at the top of the paper. So if you look at your homework, it says if g of x equals this and h of x equals this, then do all of these problems. So, yeah. Alright, last one. The f function. We go to the f function, 7 times x minus 3. But everywhere there's an x, what do you put? An x plus 1. So we are completely replacing, it's like a substitution, one variable for the other. Now what? Let's distribute. I've got 7x plus 7 minus 3 would be what? 7x minus 4? Plus 4? Point. So that was point. Good. So let's look at your homework really quick. Now, there's a lot of different types of problems that look very similar. So let me point out the ones that you want to be looking at right now. You can do problems 1, so if you'll circle these for me really quick. 1, 2, 5, 6, 7. Try those. 1, 2, 5, 6, 7. I'm going to pause this. If I forget to come back, I'm sorry. All right, moving on. Now, we're going to talk about the possibility of adding and subtracting and multiplying functions. So when you started learning this, you just learned that you can add and subtract numbers, right? Multiply, divide numbers. Then earlier this year, we add, subtracted, and multiplied polynomials. Pretty much this is the exact same thing, just with really fancy writing. So, the fancy writing, the hardest thing about this is the notation. What does this mean right here? Because it kind of looks like I need to add my functions together and then multiply by x. That's what it looks like, right? And oh no, yes. So what this is saying is I take my f function, I take my g function, I add them together, and the variable I'm using is x. That's what that means. So when you have something like this, you kind of can ignore this part. Just add the f and the g function together. Is that okay? Likewise, f minus g of x means f of x minus g of x. And then you can also multiply them as well. So these x's. Sort of. Let me show you what this means. Now, one of those three, the order matters. So like in addition, if I say f plus g or g plus f, does it matter? No, because add 2 plus 5, 5 plus 2 is the same. What about this one? F minus g and g minus f. Will those give you different answers? Yeah. So this one, the order matters. But for the most part, it doesn't. Okay, help me out because my functions are on the board. So what is the f function? What is the g function? X squared plus what? 2. I would like the answers in standard form. What does it mean to be in standard form? You guys know? Very good. I need it so that the exponents are in decreasing order. So if there's an x cubed, that one's going to come first. If there's an x to the fourth, that one will come first. So on this one, when I'm adding them together, where do you think I should start if I want it to be in standard form? Probably with the x squared. Good. So x squared. And then we look at the 7x. And then we combine those and we get nice one. All I gotta do. Yep. Do the next one. Now we're subtracting. F function is 7x minus 3. The g function is x squared. Say it again, Martin. Oh, from this. Yeah, we're using the same function. So, how do I subtract those? What did we do when we did this a few units ago? How do I subtract that? You have to distribute. Good. If you remember that, give yourself a point. We got to distribute that negative through. We call it minus x squared, then what? Minus 2. And we can ignore this. So now when we combine like terms, where should we start again to keep it in standard form? Okay. This time it's going to be a negative x squared. Compare that. Now what? And then you got the minus 3, minus 2, which would make it negative 5. Any questions with either of those two? You feel good about that? Comfortable with it? Give yourself a point. What about part C? Now we're multiplying, right? So I take the f function, I take the g function, and I multiply them together. So how do I simplify this? Yeah.
I would do 7x to everything, and you would do 3 to everything.
So 7x cubed, very good. And then 7x times 2 would be a plus 14x minus 3x squared minus 6. However, that's not in standard form, so how do I rewrite it so it is?
Combine all my terms.
7x We'll move this one up, minus 3x squared plus the 14x minus 0. Okay? Now looking at your homework, which problems are like these problems? Only look at that top section still. So 3, what else? 4, not 8 yet. 3 and 4? Why don't you try 3 and 4? Your own. I'm fairly confident that you're good, but let's just be sure. Part C. And was there a problem on your homework that did a multiply? You want to try part D as well? At least not yet. So on your note, we are working on C and D right now. A new set of functions, right? Alright, let's try this one. With part C, did I set it up okay? And what do I do next? Distribute the negative, right? So I've got a negative 2x minus 4. Then what? How do I combine this? If I have x and I subtract 2x, what do I get? So 1 minus 2 is a negative 1, right? I don't have to say x squared or anything weird. It's just x minus 2x. And then minus 1 minus 4 would be? Oh, minus 5. Good. Raise your hand if you got that. Okay. Good. So what about this next one? How do I multiply that through? It's probably easier to come backwards. At least you have a question? No. Okay. Here. It's probably easier to go backwards because there's only one term on the end. So when you multiply that, x squared times x would be what? X cubed. And then x squared times negative 1 would be a minus x squared. Did you get this one? Points if you did. 1 point. Alright, moving on. How is part D? Oh, I see why you asked which part D are we doing. Thank you, got it. How is part D, the second one, different from the other one? There's a 2 right there. So there's 2 ways you could do this. You could either figure out, is that up there? You could either figure out what h plus g of x is, and then plug the 2 into that. It's not the way I like to do it though. I prefer, and I find that you make fewer mistakes, if you find h of 2, you find g of 2, not really, and then you add them together. So how do you find h of 2? What's the h function? which is what? 4. And then the g of 2, what's the g function? X minus 1. So this would be 2 minus 1, which is 1. And then you add those together and you get 5. So what did I do there? I took the f function, or the h function, evaluated it. I took the g function, evaluated it, and then added them together. Okay, let's do it again then. Part E. Part F. Let's do F instead. This one is the same thing as saying the h of 4. Figure that out. The f of 4. Figure that out. And then subtract them. Right here? I don't know. So what's the h function? The h is squared, right? So 4 squared is 16. What's the f function? So for this one, I'm going to have 2x plus 4. And what is that? So 2 times 4 is 8. Oh, 8 plus 4 is 12. Is that okay? So you're evaluating them independently, and then what do you do between the two numbers? Then you subtract them. And 16 minus 12 is? Questions with that one? Alright, let's try part E. This one's a little bit more confusing. This one, you're going to do the f of what? 0, and add f of 0. So the f function is 2x plus 4, so 2 times 0 plus 4.
Times 0 plus 4. So then you get rid of the 3 and 2 times 0 times anything is 0, so it's 1 plus 4.
Yep. So this one right here would be 4, which means this one right here would be 4. You're right, add them together, you get 8. Are there any like that on your homework on the first section?
I don't know.
Not on that very first section. So let's just keep going. How is part G different than even those ones?
Because the n variable.
That plus 2 is at the very end. What about part H? Is this one a little bit different? Not really. So on part H, what's the H function? X squared. So if I'm doing part H and this is my input, the H function looks like this. And what do I put into it?
X plus 1.
Good. And I honestly don't care if you even leave it like that. You don't have to expand it. If you were to expand it, you would need to go like this. And then multiply it out. Right? I don't care how you leave it. You're less likely to make a mistake if you leave it. What about part I? What's the G function? Okay, so we're going to put this into the G function. Everywhere there's an X, you put the answer. Okay, there's a little bit of space underneath your notes. I don't feel like my notes covered everything you need for your homework, so I'm going to give you 2 more functions. Are they already here? No. I'm going to give you 2 more functions. Let's say f of x. So if you write them down in that kind of empty space, f of x equals x squared plus 2. G of x equals 7x minus 5. I don't know. And I have 3 more problems and then we are done. And you'll have 30 minutes, 25 minutes to do your homework, which means y'all should be finished by the time class is over. Okay, so for part A, I want you to find 2 times f. I didn't write that. 2 times f of x. This one I want you to do 3 times g of x minus 5. And this one I want you to do f of 2x minus, I don't know, what is 10? I don't know.
When you're multiplying the x squared, how squared in your answer?
Okay, so let's look at these problems. How is this different than the ones we've seen so far? So how is that one different? That 2 is on the front, right? So yeah, so this time we are going to substitute our f of x out. What is f of x? X squared plus 2. So this time, am I inputting the 2 in here? No, it's different. I'm multiplying the 2 by the function. So if I were to distribute that, it would be what? 2x squared plus 4. Questions with that one? Do you see the difference? It's not an input, it's just a multiplier. Okay, let's do the next one. This one, I've got 2 things going on. I need to multiply this g function out, right, and distribute whatever we have to. And then at the end, I'll subtract the 5. So let's start here. So 3 times 7x minus 5. And then what? Subtract 5. Distribute this. It would be 21x minus 15, still minus 5. What's our final answer? 21x subtract 20. Are you okay with that one? You're not usually quiet like this. Hold on. Okay, moving on. What about this one? This time, am I inputting anything? Yes, this time's the input. So I go to my f function, and everywhere there's an x, I put something. So that's my f of x, right? But then I still have to do what? So that's this part. Sorry, jumping. It's almost over. You're almost done watching it. Then I still have to do what? This part. Add the 10. Is that okay? Where the different pieces came from? I'm inputting the 2x. So this is my f function. This is the plus 10 from the problem. Final answer, 2x squared would be what? Say it again, Marcus. 4. Let's see that. 4x squared plus 2 plus 10 plus 12. Is there anything else you can do with that? They both have a 4. No, I'm just going to leave it. So there's no equal sign, I'm not going to divide by the 4. Just leave it. That's colorful. Thanks for watching. Peace out.